Hi everyone, my name is Angelica and my project is on reverse osmosis filtration. First of all, what is osmosis? It is a naturally occurring phenomenon where water passes through a semi-permeable membrane from a less concentrated solution to a more concentrated one. Examples of these include plant roots absorbing water from the soil or kidneys absorb water from our blood. Osmosis happens naturally without energy, where in reverse osmosis, more energy and pressure is applied. So, reverse osmosis is a water purification process that uses a semi-permeable membrane to filter out unwanted molecules and large particles, such as contaminants and sediments from drinkable water. Examples of this include chlorine, salt, and dirt. Semi-permeable membrane it allows some but not all atoms or molecules to pass. Reverse osmosis can also remove microorganisms. It makes water clean to a molecular level, so only pure H2O is left. Here is a diagram on how reverse osmosis works. There's pressure that is applied to the water, where then there's a semi-permeable membrane, which is the orange, and all the contaminants and dirt would be left behind while the fresh water is pushed through. So the parts of RO filtration include a pressure and then 4 stages. So first, there's a high pressure pump used to increase pressure on contaminants and force water across a semi-permeable membrane. It typically also has 4 stages of filtration. The first one is a sediment filter. It removes the largest particles to prevent clogging of subsequent filters. So this includes dirt, sand, and rust. Second is a pre-carbon block. It uses activated carbon to prevent anything larger than flour passing through. It also attracts and bonds with positively charged ions to prevent chemical compounds such as chlorine and chloramines from passing through the third filter. If those compounds get in, it gives water a bad taste and a bad smell. So in the next slide, there is a diagram. So at the top that says feed water, that's where the water is being pushed through with the pressure, where it goes into the sediment pre-filter and then the carbon pre-filter. Then after that, it goes into the RO membrane. So the third filter was what I mentioned earlier, which is the reverse osmosis membrane. And that removes molecules heavier than water. So this includes sodium, high levels of lead, dissolved minerals, and fluoride. And the last filter includes the post-carbon filter. This filter polishes the water right before it gets out the faucet. So sometimes after filtration, but before post-carbon, a storage tank would be inserted where water is held until needed. The RO system continues until the tank is full and then the valve shuts off. But the tank can be very useful since the filtration system is slow, where in about a minute there's only 2 to 3 ounces of RO water produced. So since RO filtration does produce highly purified water, it can be used in a variety of locations. Common ones are under the sink, so this would belong in homes and kitchens specifically, or boiler feed water treatment, which reduces solid contents of waters prior to feeding into boiler for power generation. There's also pharmaceutical, where there's an approved treatment for producing U.S. pharmacopoeia-grade water, food and beverages, or semiconductor wastewater, which is an accepted component of treatment for ultra-pure water. And lastly, there's metal finishing. There's a case in Trinity, Alabama, where they had a failure at a water plant, so they resorted to using RO process to reduce 99% of contaminants found in their drinking water. In this diagram, it shows the RO filter models. Both of them are whole house models where they would belong like in a basement and it would filter out the water throughout the house. However, these are quite rare. So there are a lot of strengths and some limitations to the reverse osmosis filter. First, for strengths, it can rid up to 99.9% of all contaminants, sediments, or particles as small as 0.001 micron. Only carbon filtration, which is the more common type of filtration found in our faucets, it can remove particles as small as 1 micron. So the RO filter can definitely remove a lot more of those tiny contaminants and sediments. Other strengths include harmful dissolved contaminants being reduced, sodium is reduced, the bad taste and odors are reduced, and it is also more environmentally friendly than bottled water. The wastewater is either sent to a water treatment plant and diluted to make it easier to treat, or riverbeds for nature to filter through hydrologic cycle. These also fit under kitchen sinks for the under the sink model. There are also some limitations, as I said previously. So some of them are they can be used in a variety of places, but cannot or is rare in whole house use, showers, pools, apartments, and agriculture. They are not commonly seen in an entire house just because the tank is so large, and also because it is a slow process. So trying to use RO throughout the entire house would take a lot of time, even to fill up the tank and for your water to be purified. And the same goes for showers and pools. And for agriculture, it's only placed sometimes just because not all plants thrive with RO water unless used for hydroponic farming. Other limitations include they need good water pressure supply since filtration relies on pressure initially. It can be expensive. The under the sink use starts at $200 to $400 without any customizations, and it is a very slow process. So I said earlier, it does take 1 minute to produce only 2 to 3 ounces of RO water, and this is why it is not recommended for large water supplies such as the ones listed above. For the capacity, it can be used whenever is necessary. The pre and post filters will need to be replaced every 6 months to 1 year. An RO membrane should be replaced every 2 to 4 years, and the RO system can actually last up to 20 or more years with proper care. And these are my sources, and thank you very much for listening to my presentation.